In this video, we're going to look at the mathematical relationship between all four characteristics that we use to describe how gases behave, and this is pressure, volume, temperature, and the number of moles. We're going to call this the combined gas law. And so if you take Boyle's, Charles, Avogadro, and Montan's laws and combine them all together, we can see that there is a relationship between the pressure, volume, moles, and temperature. And if you put them into an equation where you have the pressure times the volume divided by the moles times the temperature, that also should calculate to be equivalent to a proportionality constant, K. And if we set this equation or use this equation in two different conditions, condition 1 and 2, no matter the different conditions of the pressure, volume, moles, and temperature, they should always equal that proportionality constant K. And if this is true, then we should be able to set together P1V1 over N1T1 equals P2V2 over N2T2. This is called the combined gas law. Some chemists will actually exclusively use this particular law instead of using each individual Boyle's, Charles, Avogadro's, and Montan's law and having to remember which one is which relationship, and instead just uses the combined gas law. And if they're using this equation and a problem doesn't describe or says that a particular characteristic doesn't change, they can just remove those variables from the equation. So how about we try that in an example problem? So this problem says a high altitude balloon is filled with 1.41 times 10 to the fourth liters of hydrogen at a temperature of 21 degrees C and a pressure of 745 torr. So you now have volume, temperature, and pressure in one particular condition of that balloon. So we're going to call that condition 1. And then it says, what is the volume if the balloon at a height of 20 kilometers, where the temperature is negative 48 degrees Celsius and the pressure is 63.1 torr. So what we have been given here is the temperature and the pressure of condition 2, and it's asking what the volume happens to be. So that's what we're going to add to that condition. And so in this particular case, I'm going to set down my combined gas law variables of pressure, temperature, volume, and moles in my condition 1, and then I'm going to figure out what my pressure, temperature, volume, and moles are in condition 2, and I'm going to tease those out of the problem. So for condition 1, the volume was 1.41 times 10 to the fourth liters. The temperature was 21 degrees Celsius. The pressure, 745 torr. And nothing was discussed about the pressure or the number of moles. And so we'll come back to that just in a second. Pressure 2 is 63.1 torr. Temperature 2, negative 48 degrees C. And the volume is what we're going to try to determine. And again, the number of moles was not discussed. And if you think about this, if you have a gas of hydrogen inside a balloon, that amount of gas, if we're not taking into account any kind of leakage of the balloon or anything like that, then the amount of gas in the balloon at the altitude of 745 torr, that pressure, compared to the 20 kilometers above and that pressure, the amount of gas is still the same. So it doesn't matter what that value happens to be. You don't actually need this variable because it's going to be the same either way. And so when we're writing this equation, P1V1 over N1T1 equals P2V2 over N2T2, if you don't have the value or the value ends up being the same from one condition to the next of a variable, you can just get rid of that variable. And so now you have this version of the combined gas law that only has the things that we have values for. So before we use this equation, we need to make sure that we're in proper units for temperature. So 21 degrees C is actually 295 Kelvin, or sorry, 294 Kelvin. And negative 48 degrees Celsius is 225 Kelvin. And everything else, as long as the values of pressure are in the same type of unit and the volume is in the same type of unit, you can just leave those as to what they are. And so I'm going to go ahead and plug everything in. So I have 745 torr for P1. V1 is 1.41 times 10 to the 4th liters. And T1, 294 Kelvin, equals P2, 63.1 torr. We don't know V2, but T2 is 225 Kelvin. And so we're going to solve for V2. In order to do that, you multiply by the reciprocal of this set of information. So we'll have 225 Kelvin divided by 63.1 torr on both sides. And these will cancel out, and that leaves you with just V2 on the right-hand side. And if you cancel out the units, torr cancels, Kelvin cancels, and that leaves you with liters. So we just do our math here. In my calculator, I get the value of 127,403 liters. But let's go back and make sure they're in proper sig figs, which is going to be 3. So we're going to use that to round or not round, and we're going to stay down. So 127,000 liters is our volume. It should be of the balloon. And that does make logical sense since we're going up to higher altitudes, volumes of balloons should increase as the pressure should decrease. So what we've learned in this particular video is the combined gas law and how we can use that in a problem. And in this particular case, we didn't need the use of moles, so we just took that out and used pressure, volume, and temperature. Okay,